Hi guys. Alright, today we're going to talk about the chain rule. So the chain rule is also sometimes called the outside-inside rule or the inside-outside rule. I prefer the outside-inside rule because when you take the derivative with respect to x of the composition f of g of x, you take the derivative of the outside function, keep the inside function, and then multiply by the derivative of the inside. So you're taking the derivative of the outside times the derivative of the inside. So in words, we take the derivative of the outside function, leaving the inside alone. Then we multiply by the derivative of the inside function. Okay, so let's look at an example. Here we have y equals 3x squared plus 2, that quantity cubed, and we want to find the derivative. Now, the first thing you need to do is you need to realize that there's an inside function and there's an outside function of cubing. So when we find the derivative, dy dx, we take the derivative of the outside function, which is something cubed. That means bring down the 3 and decrease the exponent by 1. But we're supposed to keep the inside the same and then multiply by the derivative of the inside. And the derivative of the inside, the derivative of 3x squared is 6x, plus the derivative of 2 is 0, so we have this. Now, when we do the chain rule, I only want you to multiply or expand monomial terms. I do not want you multiplying out that binomial squared, okay? I only want you to say dy dx. We're going to multiply the monomials. 3 times 6x is 18x times 3x squared plus 2, that quantity squared. Because when we start using the derivatives for things, we're going to need them in factored form. And if we multiply it, then we're going to have to undo that. So we're just going to get in that habit for now, okay? Let's try another example. So now we have y equals cosine 3x. So this time our outside function is cosine and our inside function is 3x. So the derivative with respect to y of x is, now the derivative of cosine is negative sine of, and we're going to keep the angle 3x, times the derivative of 3x is 3. Now some of you are going to be able to jump to this right away. Some of you will down the road, and that's okay. You don't need that first step. If you can see this right from the beginning, that's okay. Now the next one, y equals sine to the 4th x. Some of you might not realize that the inside function is really sine x, and the outside function is x to the 4th, is raising to the 4th. So when we take this derivative, we do the derivative of raising to the 4th, so we bring down the 4, our new exponent is cubed, we keep the inside, times the derivative of the inside sine x is cosine x. Now we're going to rewrite this nicely. Dy dx equals 4 sine cubed of x times the cosine of x. There we go. Beautiful. Now, sometimes the difficulty with the chain rule is recognizing what the outside function and the inside function is. So when we go through these, we're going to look for the outside function and the inside function. So you can see in the example one, where h of x is the quantity x squared plus 3 raised to the 4th, that the inside is x squared plus 3, and the outside is raised to the 4th, so that's x to the 4th. Then you take the derivative of 4x cubed, put the inside in there, and then take the derivative of the outside, and then your final derivative is you're going to take this times this and multiply any monomials. So let's try this. Okay, so if we have h of x equals the square root of 3x to the 5th plus 2x minus 4. Our outside function is the square root of x, our inside function is 3x to the 5th plus 2x minus 4. Now be careful. When we look at this outside function, that's also x to the 1/2. So when I want to take the derivative, I bring down the 1/2, subtract 1 from the exponent. So this is 1 over 2 times the square root of x. So now when I want to rewrite this and keep the inside the same, I'm going to put that inside 3x to the 5th plus 2x minus 4. I have to expand my fraction line and my radical. Okay. Now the derivative of g of x, the derivative of 3x to the 5th is 15x to the 4th, plus the derivative of 2x is 2, minus the derivative of 4 is 0, so I do not need that. Now, when I want to find h prime of x, that is 1 over 2 radical 3x to the 5th plus 2x minus 4 times the derivative of the inside, 15x to the 4th plus 2, or simply h prime of x is the 15x to the 4th plus 2 all over 2 times the square root of 3x to the 5th plus 2x minus 4. There we go. Let's try one more. So here we have h of x is 3x minus 1 to the 6th. So my inside function, that's the easy one to find a lot of times, is 3x minus 1, and the derivative of 3x minus 1 is just 3. Now the outside function is raising something to the 6th. Now, some people like to do the step where you find the derivative 6x to the 5th, but some people that confuses them, and we like to write 6, keep the inside, raise to the 5th, and then just put the inside in there. So if you want to skip this step, that's okay. All right, now h prime of x, we're going to take that 6 times the quantity 3x minus 1 to the 5th times the derivative of the inside is 3. Now we do have some monomials to multiply. 6 times 3 is 18 times the quantity 3x minus 1 raised to the 5th, and we have our derivative. Okay, let's up the game just a little bit. Now before we do this derivative on y equals cosine squared of 4x, I want you to take a look. This is y equals the cosine of 4x squared. Well, that looks like cosine 4x is the inside and squaring is the outside, right? So, okay, dy dx, because the derivative of y is dy dx, take the derivative of the outside, the squaring, we bring down 2, we're going to keep the inside and we're going to subtract 1. Now we're going to keep the inside. Now here's the catch. We're going to multiply by the derivative of the inside. However, inside the cosine x is a 4x. This is a double chain rule problem. So we're going to take the derivative of cosine, which is negative sine, and we're going to keep the inside 4x, but I still have to multiply by the derivative of 4x, which is 4. Now, the monomials we've got a 2, we've got a negative 1, and we've got a 4. So that's negative 8 cosine of 4x, sine of 4x, and there is our derivative. Haha. Let's also take a look at the next one. Again, before you take this derivative, remember the square root of x is really x to the 1/2. Cosecant of 1 minus 2x. All right, the derivative of y is dy dx. The derivative of x to the 1/2 is bring down the exponent, keep the x, subtract 1, so it's negative 1/2. Now, if we look at cosecant, cosecant is on the outside and the inside is the angle. So almost always a trig function is a chain rule. So the derivative of cosecant is negative cosecant of keep the angle times cotangent of keep the angle. So now I'm going to keep my angle 1 minus 2x, 1 minus 2x, times the derivative of the angle is negative 2. So I have dy dx. Now this first term here, I have 1/2, but the negative 1/2 in the exponent here tells me to put the square root of x in the denominator. Then I've got a negative 1 times a negative 2, which is going to give me positive 2 cosecant of 1 minus 2x times cotangent of 1 minus 2x. We just multiplied those monomial terms. All right, one more. Ready? Here we go. All right, this looks like a what rule? This is a product rule because we have multiplication. And you're not going to expand that because you're not going to raise that 3x squared minus 5 to the 5th and then multiply by x minus 1. So the derivative of y is dy dx, and the product rule says take the derivative of the first, so the derivative of 1 minus x is negative 1, times, keep the second, 3x squared minus 5 raised to the 5th, plus, now we're going to keep the first, 1 minus x, times, now we're going to take the derivative, but this is a chain rule. So we're going to have to bring down the 5. We're going to keep the inside. The new exponent is 4. So when we keep the inside, it's 3x squared minus 5 times the derivative of 3x squared minus 5 is 6x. Now we got a little bit of work to do here. So we have dy dx is the negation of the quantity 3x squared minus 5 raised to the 5th, plus, now monomials, I've got a 5 and a 6x, so that's 30x times a 1 minus x times the quantity 3x squared minus 5 raised to the 4th. Now, yes, technically, you're done, but I want you to see some more algebraic manipulation because I think it's important that you can do this. If you notice, this term has a 3x squared minus 5, and so does, after this addition sign, so does this. So we can take out a 3x squared minus 5, but not only can we take out a 3x squared minus 5, we can take a 3x squared minus 5 to the 4th. Now, that's going to leave us in the first term with the negation of a 3x squared minus 5. And in the second term, it's going to leave us with a plus 30x times 1 minus x. All right, so we have 3x squared minus 5 to the 4th. Now inside, we've got negative 3x squared plus 5. I'm just distributing that negative. Now I'm going to distribute the 30x, and I'm going to have plus 30x minus 30x squared. So now I have dy dx equals the quantity 3x squared minus 5 to the 4th, and I'm going to combine like terms. I'm going to have negative 33x squared plus 30x plus 5, and now I've completed my derivative. Woohoo! Gets no crazier than that, hopefully. All right, so there you go, guys. There's the chain rule. Have a great day.